Hey Precalc, hope you're doing pretty well. I've definitely been better, but I'm here at Good Sam, and looks like they're going to keep me in overnight here, so this will be the second night that I've been staying in. And yeah, I'll be released tomorrow. That'll be Tuesday in the evening. They're going to kind of make sure my levels go down, but yeah, the event was great. Hardest thing I've ever done in my life. Obviously, I'm paying for it now with an IV here. I've got a condition called rhabdomyolysis. I think I'm saying that right. It comes from the overexertion on your muscles. So never had that happen before, but my CPK levels were off the charts. So basically, what they've had to do is they've had to just keep an IV running through me this entire time and just keeping things flowing. So it's more precaution than anything else. So I'm feeling good. Lower back's a little sore. Legs feel fine. Everything else is fine. So hopefully I'll be back at it on Wednesday and I'll be able to help you out. But quick shout out to students here. We got Haley and Jermaine. Congrats on being homecoming king and queen. I'm sorry that I missed that, and missed you all looking at your best for the homecoming dance and all of that stuff. So the other thing is I obviously missed Monday. That would be today, for me at least when I'm recording this, when you were wearing your blue and pink. So I hope somebody took a picture. If you can, someone try to post that on the Google Classroom so that I can, see what you guys look like and see your smiling, happy faces. It'll definitely brighten my day. So that'll be good. So I think I covered my bases here. Okay. So, yeah, that's the other thing. So tomorrow, all I'm going to be doing is laying here all day with this IV hooked up to me. So I'm going to have my computer up and be on the Google page there. Try, if you're struggling with the worksheet, which is, I'll give you fair warning now, it's one of the harder sections that we have to deal with. So if you're having trouble with that, just shoot me a Google Hangouts message, and I'll pull up a video here just like we're doing here, except for it'll be live, and you can ask any questions you might have. Then I'll pull up my whiteboard and try to show you what I can do there. Okay. So please, yeah, don't be shy with that. Please don't slack off that. Look, I think your sub's going to be today would be Mr. Michelson. So I don't think he'll mind either. So just explain the situation to him. Say, hey, we're going to do a Google Hangouts message. The other thing is, if you can, this would be awesome, but figuring out a way to project this video up onto the projecting screen, so it's almost like I was there, just writing on the small whiteboard here instead of the big one. So if you can figure that out in the next couple minutes, you can pause this video, see if you can hook up your computer Chromebook to the projector, and then see if it could project over. You're probably going to need some sort of converter, so I don't know. It might not even be worth it, but whatever. Maybe just put one of these a Chromebook in the front of the room and put it full screen, or on an individual basis, just watch this. Okay. All right, so now that I've effectively wasted about 3.5 minutes, let's talk about the section this week. So, section this week is on 5.1, the fundamental identities. Okay. So basically what we're doing is we're going to be talking about the trig functions and how to basically simplify these things. Now, it's one of those sections where I feel like it doesn't serve, I'm always going to be straight with you with a lot of this stuff. It doesn't really serve a purpose in the real world. What this does do for us is it allows us to rewrite a lot of confusing, difficult-looking functions into easier-looking ones so that it's easier to plug in. It also comes up a lot in calculus class when you're trying to take the integration of a function. Sometimes it's going to be hard to take the integration of, let's say, secant squared, but you might be able to take the integration of 1 over cosine squared or something like that. So you're not supposed to know what that means, but basically just know that these principles that we're learning this week has relevance in terms of higher math, but that's about it. So if you don't grasp it right away, just gut through it this week. And again, it is very difficult, and I will say it's the most frustrating thing about it is that it takes a while for you to quote unquote see how to do it. And you just have to kind of mess around with things you know to be true in math, and just kind of see where it takes you. And I'll give you some strategies with it, and I'll give you some kind of the way I think about things, but a lot of this is just going to have to depend on what your skill level when it comes to math. So again, got through the week, and I'm only assigning one worksheet, and then that's it. Okay, so the first set of identities are called the reciprocal identities. Okay, you should be pretty familiar with these already, but basically it's being able to write the sine, cosine, or tangent as its reciprocal, the cosecant, secant, cotangent, and then write vice versa. So make sure you copy these down. So the other thing about these is, we talked about it before, where it's like sine is opposite over hypotenuse, and then cosecant is hypotenuse over opposite. That's what it means to be reciprocals. When you flip a fraction, then that's what it means to be reciprocal. But you could also think of it in terms of something like this, where it's like, okay, sine equals 1 over the cosecant. That's what it means to reciprocate as well, is to flip it over. So that's the first set of identities that you should already be familiar with. The second set are called the quotient identities, and I'll kind of pop it up here. I'm not sure if you can see that pretty well. You've got tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. So make sure those are copied down as well. So what this means is, if we see sine and cosine here as a fraction, you should try to think about how you can convert it to tangent, or sometimes vice versa. Sometimes the best thing to do with a lot of these simplification processes is to convert everything into sine and cosine and just see if things cancel out. So this is a quick way to convert from tangent to sine and cosine. And there's more to this, but I'll come back to that in a second. The other thing to think about are these three right here. In all honesty, these are called the Pythagorean identities because they should actually kind of look familiar in structure. You've got cosine squared plus sine squared is 1. So think of it this way. So remember that 1 here, when we chose our hypotenuse for the right triangles last week, we said we were going to make the hypotenuses 1, right? So if you think about it, and this is, I'm kind of stretching here, but basically the cosine is the adjacent over the hypotenuse. So that's going to be the adjacent side of the triangle. So that's kind of like your A value. Sine is going to be opposite. So if I'm looking at the triangle here, let me just draw it out. It'll be easier. So if I've got a right triangle here, and this is the adjacent side, and this is the opposite side, and this is our hypotenuse. So if I'm looking at this and I'm saying, okay, opposite, or I should say sine is opposite over hypotenuse, then that's really saying it's just opposite, because opposite over 1 is just opposite. So if I'm looking at this, it kind of makes sense in terms of the Pythagorean theorem. You say, okay, the cosine squared plus the sine squared is equal to the hypotenuse squared. So that's kind of where these things come from. The other ones come from like similar, switches here, where we just kind of use the formulas that we have up there. But it's good to have these written down. The other thing is, and that's what I was about to say about these other ones here, is that these are just the fundamental identities, and a lot of things can come from it. So here's what I mean by that. So let's say we had something like tangent is equal to, just let's say tangent, and you wanted to convert that to sine over sine over cosine. That's one way to do it. But you could also have something like this. If tangent of theta is equal to sine over cosine, then we could also say something about sine, right? So if this is like this weird mirrored effect here, okay? If this is true over here, okay, then we could also make a conclusion here. So what we can say then, if we were trying to solve for sine of theta, we could multiply in this blue writing here, you could multiply both sides by cosine, and you would have something like this. You'd have cosine of theta times the tangent of theta. Okay. You understand where I got this? So hopefully. So you see, I started with this fundamental identity here that we know to be true, and then said, okay, what if we wanted to find another identity, or like just had another one, and maybe knowing what sine is, you could multiply by cosine on both sides, and suddenly have this one. Likewise, you could have something like this. You could say, okay, cosine of theta is, let's see, that would be sine over tangent. Okay? Just a little bit of algebra magic here to get to this one. But these two things kind of both follow from it. So there's a lot of things that follow from these theorems. So for example, just in another example, let's look at that second Pythagorean identity here and say, okay, so that means that the tangent squared of theta is equal to 1 plus secant squared theta. Okay? And what did I do here on that second line? All I did was I took the secant squared theta and I added it to both sides. So it canceled on the left, and then it appears on the right. And honestly, this is the one I've seen more often, but I've given it to you like these three because it's easier to remember, I guess, or it kind of makes sense to have all the ones lined up. But usually you'll see something like this, and it'll say, okay, clean that mess up. And you can just replace it with tangent squared. Alright, so the long and short of this is this thing right here. Here's what I want you to remember, if nothing else about this thing. I want you to remember this identity right here. So I'm going to circle it here for you. Okay, and I want you to remember this one right here. Okay. I have a feeling that you guys can already remember these, and that kind of goes without saying that if you remember each of these three things, then obviously they follow of these things. So hopefully you already know these. I went on a rant about how they were named and just got to remember the reciprocals basically. But these are the two big ones, okay? With really just these two, you can probably tackle 9 out of 10 problems this way. Just by knowing these guys. And even if you aren't able to tackle the problems completely, you should at least just like be able to see some stuff like, you see a tangent squared, you might think, okay, there's something here. Okay, I see a tangent squared in this identity, so maybe I'll use that identity. Okay, so in the next video here, because I'm running short, I only have 15 minutes to record on this one, so I'll post a second video here with some examples. What I'm basically doing, so these are just the identities, these are truth values, these are things that we can use that says, okay, we can replace tangent with sine over cosine. If we see cosine over sine, we could replace it with cotangent. If I see a 1 over sine, I could replace it with cosecant. That's what all of these things mean. They're just kind of like the tools in our tool belt. So in the next video, I'll show you how we actually use these to solve the problems that we care about in the book.